Hello guys, welcome to our lesson number 2. I hope you can see my camera and hear my voice. So welcome everyone. All right, so this lesson is lesson number 2, and we know that some of you are still in the process of signing the contract and paying the registration fee. So we decided to make this class also free for everyone without any passwords. But starting tomorrow, you would only be able to access classes with a personalized password if you pay the registration fee and finalize signing up the contract. Okay, guys, so please, today is still free, no password, but starting tomorrow, you only would be able to access with the password. So please finalize all the information by the end of the day. If you have any questions, feel free to send email to support@jobeasy.co, and I'll share with you the email again, and they will be happy to help you with all the questions. All right, so let's start. We will have few topics to cover today. So first, we'll start with a quick introduction to our tool that sometimes we use. It's called Chrome DevTools. And Lana.
Hello, sorry, I'm having a little bit of technical difficulties here on my machine, but you should be able to see me and hear me now. Is everything fine?
Yes, we can see you and hear you well. The class is all yours. Thank you.
All right, very cool. So let me take over and let me start sharing my screen. So today we're gonna cover a few topics, just like Yuri mentioned, and we actually gonna start today's lesson with one of the tools that is pretty helpful sometimes for manual testing, and this is Chrome Developer Tools. So Chrome Developer Tools is something that is totally free, and it's actually available to everyone. So if you want to play with it, if you want to try it out yourself, feel free to do it. The only thing that you need to do in order to have these tools installed on your machine is basically you need to have Google Chrome browser downloaded and installed. And after you have it, you can actually work with Chrome Developer Tools. So I have Google Chrome browser, and I will be showing you today how to access it. Besides this, if you have Microsoft Edge, you can also access this tool. Microsoft Edge is built on Chromium as well and has a separate set of tools, which is super similar to Chrome DevTools. And in fact, it pretty much looks identical. So if you have Microsoft Edge browser, you can also just follow after me and you will be able to access the same functionality. So now a few words about some problems that we can actually solve in manual testing.
Excuse me, Lana. Okay, so guys, don't follow right now what Lana is doing. You can rewatch the video after, okay, and just play with it. But right now, just focus on the class. No need to do anything. Just watch the video, okay? Thank you.
Thank you, Yuri. Yes, so for now, just basically concentrate on what I'm doing and try to understand this. So what I would like to start with is just talk quickly about some problems that we can actually solve with using Chrome DevTools. So sometimes when we do manual testing, we actually need to test our web browser with different mobile devices, right? So if you have your mobile app, if you have your mobile web and you want to check how it is working on different mobile devices, you actually don't need to have all these different varieties of mobile devices. You can actually just use Chrome DevTools and simulate that behavior. Besides this, we can do some additional things like testing location features, working with web elements, network activity, and so on. But let's start with the very first test case, and let me actually show you the very first case and how we can simulate our mobile devices testing by using Chrome DevTools. So I'm just going to open a web page. I actually have Amazon.com website open right now on my browser. So it's basically just a website. And now let's imagine the situation when I actually want to test this particular website on a mobile device, right? So I want to see how this website will look in case I'm using iPhone or Android device. So obviously an easy way to do it is to actually use a real mobile device. But if we don't have it, like what can we do in this case? So for this case, we can use Chrome Developer Tools. In order to open it, all you need to do is just right click on the screen and go to inspect. So after you do it, you will basically see the menu that will open. This is how it looks. For me, it opens by default on the right side. So I see this menu right here, but it is possible that it will open on a different site for you. It's basically just a configuration, so you can actually put this tool at any side of your page, whatever you prefer. So let me show you one more time. Just basically do the right click on your page, select inspect, and then you will see this tool opens like this. Now, in order to simulate our website behavior on a mobile device, all we need to do is just use this toggle right here that will basically simulate the behavior on a mobile device. So when I click on it, you can see that the size of my screen becomes much smaller. And over here, by default, I have iPhone 5 SE selected. So after I refresh my page, you will be able to see how this particular website looks for users on iPhone 5 or SE sizes. So now you can actually scroll down and you can play with our web interface just the same way as if you were on a mobile device, and in particular on this iPhone device. Now over here, you can actually select from multiple devices. So we can go for something bigger. Let's go for iPhone Plus. Also, let's refresh the page. And you'll be able to basically simulate this device's behavior and see how your website looks on this particular device. Now, if you want to test on Android devices, there's also this possibility. All you need to do is just click on this device dropdown and click on this edit button right here. And this will actually allow you to add additional devices for emulation. So over here, you can actually select a certain device. Let's go for Nexus, for example. Let's go for Nexus 10. And I don't know, let's add one more to the list. Let's select Galaxy Note 2, for example. And after you just do this check boxes over here, after you just check them, you can go to this drop down and you will see that this devices actually pop up right here. So now we can also test how our interface will look on a certain Android device. So we can take Nexus, we can refresh the page, and now we should be able to see how our web Amazon.com website will look in case we actually using Nexus 10. So we can basically test on this device as well. So this is pretty convenient. It's pretty helpful when we don't have a certain device and we want to verify certain behavior. So all we need to do, again, just have Google Chrome or Microsoft Edge browser installed and just access Chrome Developer Tools. Besides this, when you work with mobile, let's go back for, I don't know, let's pick iPhone. Besides this, when you work with mobile, very often we need to have ability to rotate the device, right? So we can keep our device like this vertically, and we can also use it horizontally and rotate it. So this ability is also built into Chrome Developer Tools as well. So this button over here is actually responsible for device rotation. So if you click on it, you'll be able to rotate your device from portrait or vertical mode into landscape or horizontal mode. And now we can actually see how our web looks on a mobile device in case we rotate this device horizontally. So pretty convenient. Besides this, you can actually rotate it in any way you want. So let's go to click here on three dots and go to more tools, sensors. So if you go here, you will see a menu that will look like this. Let me make it a little bit bigger. And in this menu, you can see devices orientation. It's currently set to off, but you can actually select custom orientation. And here you can actually rotate your device in any position that you'd like to test. So this is pretty handy in case you're working with some sort of a web app that changes its behavior depending on the way you are holding your device. Let's turn it back off and let's go back here. So now the last thing that I wanted to mention here is that when we test our web and when we test it on our mobile phones, very often we need to test the cases when our users don't have good Wi-Fi, right? Because when we use mobile devices, very often we are not on Wi-Fi. We're using some sort of our services like LTE or 4G, 3G, whatever. And obviously the speed, the connectivity of it, it's actually slower than if our device was on a pretty good, strong Wi-Fi. So this kind of cases, we usually also want to verify just to make sure that our web, our interface loads as expected. And for this kind of cases, Chrome Developer Tools has this menu right here, so this dropdown. It's currently set to online. So online simulates a very strong connection, basically the same connection as your Wi-Fi. But you can actually set it to something that is a little bit worse. So if we go for, let's say, mid-tier mobile, let's do this, and refresh our web page, you will notice that it will take a little bit longer for this website to actually load. So after I started refreshing the page, you can see that it takes some time for components to actually load. I can start scrolling things down and you see that we show users some basically loading images, basically clarifying for users that we are still working on it. We are still loading more content. This is very important for users because you want to make it clear for users that your website is still loading, it's still working on providing more content. So users will actually stay on this page and they will wait until the content loads. So they will keep on waiting and they will not, be just leaving our website. So this kind of things are pretty important for users. So it's clear for them and they don't get into, ambiguous state where they are not sure what's happening. And obviously this kind of tests is also pretty important to verify when you work with mobile web. So again, I'm just using this menu right here. Mid-tier mobile is the one that is similar to 4G. Low-end mobile will be even worse, something similar to 3G. And obviously, it will take even longer time to load. But what's important for us is to basically understand that even with low connection, our website still works. It doesn't break. And moreover, our website should indicate to our users that it is still loading. So our users will wait for that and will not leave the website. Now, after you are done testing a certain page, don't forget to set this setting back to what it was. So you will need to set this connection back to online. So this website will start working fast for you. And in order to exit mobile view, you just click on this toggle one more time and refresh the page. After you do this, you will see that this website is back to the standard view, to the same view we had when we just started to work with it. So now we basically get the same experience as users who are using this website on their laptops, on their desktop computers. So that's basically it. That's one of the pretty convenient tips on how you can actually test your website on a mobile device without actually have a necessity to touch any mobile device, and you can just use Chrome Developer Tools for this. Now, the second thing I wanted to quickly show you today is another problem that we sometimes need to solve when we work with web testing. And this is testing location features. So I have a website here open. This is safeway.com. Safeway, for those of you who are not familiar, it just basically are grocery stores. And they have a location feature on their website. So basically, on their website, you can go to map and you can find a store that is closest to your location. So if I open this page and if I click on this arrow right here, it will basically detect where my user is, and it will show me the stores that are close to my computer. So those are the stores that are pretty close to my area, actually. Now, this kind of feature is pretty common. We see it a lot for websites that are devoted to different chains, like restaurant chains or maybe grocery stores. We often see this kind of functionality on a lot of e-commerce websites that store different products or clothes, and they allow you to find stores that are next to your location. So obviously, as a QA engineer, if you ever work with a website like this, it's important for us to test this feature and understand that this feature works as expected and it actually shows the right location. So it actually shows proper restaurants, stores, whatever we're looking for next to our user. And in old times, what people would do, they would actually take their devices and just try to drive different places and see what kind of information they see on map. So they will verify that from different locations, things still work. But these days, we don't have to do anything like this. If you have Google Chrome browser, you can actually access Chrome Developer Tools, and you can basically simulate your location. So again, I'm just going to do the right click. From here, I'm going to go to Inspect. And after, let me make it a little bit smaller so you see the map. And after Chrome Developer Tools is open, so after you see this, we click on these three dots over here, go to More Tools, and here we select Sensors again. So three dots, More Tools, sensors. Now let's click here, and you will see this top feature right here that is called location. So this feature is actually responsible for changing your location. And here you can actually select a certain location that you would like to use and set your location to something different. So you can actually over here select different locations. So let's say Mountain View, for example. And now this feature will actually override your browser. So when you will use your Google Chrome, after you load your page and search for a certain location, if you have this feature turned on, you will be able to actually simulate a different location. And basically now you can see that after I clicked on the search, I actually no longer see Concord or Walnut Creek area. I now am seeing Mountain View over here and some cities next to it. So my map is now thinking that I am actually in Mountain View. And this is how I can verify that these locations are correct. So the map functionality is working. And no matter where I am, it is actually detecting location properly and shows me the stores next to me. So let's select something else. Let's go for San Francisco just to make sure it's working. So again, just enable it right here. And after you enable it, all you need to do is basically just refresh your page. And after you refresh your page, let's wait a little bit until it loads. You just click on this button to actually search for the stores that are next to you. And now you can see that location is set to San Francisco. So now it starts showing me the stores that are around San Francisco. So this is basically how you can make your browser think that you are somewhere else. And again, this is super helpful and super useful when you work with any kind of e-commerce websites and you test location features that will verify closest restaurants, closest stores, and whatever your website is selling. So in order to turn it off, don't forget to turn it off after you use this feature. Just go back to this menu and select no override. So after you select no override, your location basically will be turned off and your website will start finding out your real location and will basically display you the experience that you should be getting as a real user. So your location will be back to the real location of your computer and you'll be able to see the stores that are next to you. So again, just don't forget after you use this feature to set location to no override so you keep on getting the right experience. So that's basically it. In order to close Chrome DevTools, I'm just clicking on this closing X icon. And here we go. Now I can work with my website the same way as before. So this is how we can use Chrome Developer Tools. We've just looked at a couple of problems. So first of all, we looked at how to simulate our mobile device behavior. So I hope it's clear for you that you don't actually need to have a mobile device in order to test your web experience, and you can actually use Chrome Developer Tools for that. We've also looked at testing location features. So again, if you need to test any kind of map functionality, you no longer need to go travel different areas. You can just use Chrome Developer Tools, override your location, and basically see how your map functionality works, how your map functionality behaves, and make sure that it is working as expected. Besides this, Chrome Developer Tools is actually pretty powerful. So Chrome Developer Tools also allows you to do a lot of other things. So first of all, you can actually view your web elements with Chrome Developer Tools. So if you ever need to check that your web element has a certain style or a certain color or a certain size, or if it is a text that it has certain font, a certain size of the font, and so on. If you ever need to check that, you can also do it using Chrome Developer Tools. So Chrome Developer Tools is pretty often used by designers as well when they test user interface and verify that web elements match their design. Besides this, Chrome Developer Tool is pretty useful when you need to test your network activity. We will be spending about hour during our course talking about how our client side communicate with the server side, and we will actually look into this feature in the future, and I will show you also how to view your network activity, how to analyze how your interface basically talks to the backend of your app, and how to use Chrome Developer Tools for that. That is another thing that is pretty helpful and can actually help you understand your application better. Besides this, Chrome Developer Tools has a lot of other features. It can be used in order to analyze or test performance, test security of the website, and so on. Developers use it a lot as well. So if you are curious about learning a little bit more, or maybe learning and looking into more features that Chrome Developer Tools can do, feel free to just basically click on this official documentation link from our presentation. And that will take you to the official documentation of Google Chrome, where they explain with examples how to use different features of Chrome Developer Tools. Now, when working as a QA engineer, you're probably not going to be using Chrome Developer Tools very often, but the two most common use cases will be basically testing our web site on different mobile devices and seeing how it looks, making sure it doesn't look broken on mobile. And if you ever work for e-commerce website or e-commerce company, testing location features can also be pretty handy. And this is something useful when you need to test map functionality. So that's basically it. I hope it was interesting. Just a quick intro to Chrome Developer Tools. And don't worry, we will definitely spend more time talking about this tool during the course. So you will be more familiar with this, but I hope it was interesting just to start with. Yuri?
Thank you, Lana. Thank you very much. It was a very interesting lecture, even for myself. So we'll see you shortly. Thank you, Lana. All right, guys. So I know that a lot of you are thinking, oh, maybe it sounds too complicated. Maybe it's too technical. But let me put it this way. With my more than 7 years of experience working as a manual QA engineer, I think I only use Chrome DevTools maybe a couple of times. Okay, so basically, it's a cool tool to have on your resume, and in some cases, going forward in your career, it's awesome to know, how to like simulate location, because it's really useful, or how to see the different, screen size of how your website looks during the session on, let's say, iPhone versus your computer. So it's a cool thing to have. That's why we'll teach you, and you can basically add it to the resume, but will you need it at your actual work? We're not sure. But if you have it on your resume, if let's say they will ask you during the interview, do you know what the Chrome DevTools? What can you do with the Chrome DevTools? You will be able to answer all those questions. It will take you like 30 minutes to up to an hour to, to understand all those things, because it's not that complicated. All right, guys. So let me open the chat. First of all, let's start with the second part of our lesson, which would be much easier, which will cover the basics of quality assurance. And I will be going through your questions. So let me just make sure that everyone can ask any questions about the material. Yeah, so please use the chat room. I know there's a lot of us, so if some questions would be a duplicated, if I'll answer it once, I'll probably skip it going forward. But the questions that are unique, I'll try to answer all of them. All right, so let me share my presentation and let me know in the chat room that you can see my screen. Let's see, guys, give me a second. Okay, so I think you should be able to see my screen at the moment. Let me make sure I can read your comments, and we will continue. Awesome. Someone asked me, what is the equivalent of the Chrome DevTools on Windows? Guys, Chrome DevTools is same thing across all the Chrome browsers. So if you have a Windows and you can install Chrome browser, it's going to be the same thing. If you have a MacBook, you install the Chrome browser, it's going to be the same thing. So it's not dependent on the operating system of your computer. It's dependent on your browser. Depends on your browser, okay? Chrome DevTools works with Chrome, yeah? Recently, I think Microsoft Edge added similar functionality, but it's pretty common to use it with just Chrome. It's like, at my work, we use it on Chrome. Can we use Chrome DevTools on phone? I don't think so. Recordings of this lesson will be sent to your email, the one you registered with. If you don't see it, check the spam folder, check the promotions folder, check the trash folder, check all the folders. There should be a way for you to get it if you register, right? If you subscribe for the course. If you have any issues, just send an email to support, support at jobeasy.co. You can guys see it in the chat room. Feel free to save this email address. It's the one that basically will you'll get all the answers. All right, guys, so let's start real quick from the basics. Types of software testing. Let's talk about the black box, gray box, and white box. Right away, I'll tell you that we are teaching during this course, we're teaching you a black box testing. So what it means, yeah? So the black box testing examines an application without peering into its internal structures or workings. So basically, if you don't know the code, if you're tested as a user, if you tested as a basic user, right? If you have an application ready for testing, that's called the black box testing. If you test only using the code structure, so the backend, you're using the code, you're using the servers, you're using the backend, you don't really need the interface, right? That's what we call the white box testing. So white box testers, they don't really need to have a UI in front of them in order to test. So they don't really need to have a screen in order to test an application. So white box testing, it's a bit different. We teach black box testing. For the gray box testing is, so gray box testing is a kind of like, it's a mix between both. So let's say automation, like automation can be, can basically be considered the gray box testing if you use a final, like let's say a website as a user, but you also use a code structure. You use some sort of a script, some sort of a tools in order to automate and test the behavior. That would be considered a gray box testing. Another example would be, let's say you are using the UI, using the interface, the website. You have to test the software. but you have a way to check the database. So maybe you have a way to, like, let's say when you create an account, you register, you go to the website, you put your email address, put your password, and you create an account. The best way to check if you actually created an account or not would be to check the entry within the database. So if you have the access to it, if you know how to do it, that would also be considered gray box testing. Is that clear, guys? Do you have any questions about this slide, or we can continue? No questions. Let's move forward. Now let's talk about, so in testing, because testing, or QA as we call it, right? It's like a separate field of science or something, right? It's a huge industry which incorporates a bunch of knowledge, a bunch of technical information, principles, practices, and so on. So the testing types is basically testing types are basically the principles which are which the whole QA industry is divided by. So let's start with the main ones. So the main one is the functional and non-functional. So the main testing types. So when you test the software, we start with the basic construct, with a very, very basic construct. The functional or non-functional. I'll explain what it means in a second. So let me read it first, and then I'll explain. Functional testing, it's a testing of a software system or component based on its specifications. So what the system does, for example, how compliant it is with the specified functional requirements. So functions are fed input and the output is examined. Internal program structure is rarely considered. So guys, an example for you. Let's say you work for Google, right? And you are a QA engineer that, and your job is to test the, Google search field. I'm sure everyone used Google search in this chat room, right? So you have a very simple test case to check. You have, you go to the google.com, yeah? You have a search input field there. You type whatever the input, the keyword you want to look for, and you click. What do you click? You click the search button, yeah? You click the icon, whatever the search icon is there. So from the functional point of view, from the functional testing, we only care that after we click the button, the search button, Google will then give us the list of search results. Is that how it works, right? So functional testing would be to check that after we provide a certain keyword within the input field, and then we click on the button, we get the result. So we get the output. We provided an input, and we get the output from the system. And the output would be the list of our searches or suggested results. So that's what functional testing is, because we test the function, we test what the system does. Now let's talk about the non-functional part of it, because it's very interesting. I'm sure you'll understand the difference. So the non-functional, it's a testing of a software application or system for its non-functional requirements, the way system operates rather than its specific behaviors. So let's imagine the same test we did for a functional testing. So the same thing. The functional test would be to see if the Google will provide us with a list of the search results. The same test case from non-functional type of testing would be to measure how fast would the Google will be in order to provide us with the results. How long will it take? So we basically take the same function, right? The same case, but we measure different things. we don't measure the functionality. We measure, how well this functionality works. Is that clear? This basic example, it should be clear, right? So the same thing we test from functional side is we only care if, the system works or it doesn't. That's the function. So what the system does. Either the system does it or system doesn't do it. From non-functional point of view, that's why we don't really have, for non-functional, we don't have really like yes or no, pass or fail conditions. We have other things that we measure. So from non-functional point of view, we measure how well, or how the system performs the function. And let's go to the next slide. We will not really focus on all these right now, but I'll basically explain the most important ones. So let me briefly go over all the testing types. And guys, it will sound like a lot of information. And believe me, I've been working as a QA engineer for 5 years. And after 5 years, I was like looking for another job. That was like, a few years back. And one of the hiring managers called me and started asking the questions about the functional types, non-functional, all these types and those types. And you know what? Even though I had like so many years of experience, in reality, I only knew like just few of them. So it's not like I'm in walking an encyclopedia or a textbook with all the definitions and all the difference, especially where you have like 20 of them. So it's absolutely fine when you don't know something, because in reality, during your work, you only maybe touch 2 or 3 of those, 2 or 3 of testing types. But because when you go to the interview, because you have all the managers, they won't basically go by the book. So that's why we will teach you. We'll give you all the information, and we'll make sure that you will be able to explain all the types. If it comes up during the interview, that you would be ready, even though maybe you will never need it in your career at all. All right, guys, so let's talk about the functional types. Unit testing is performed by the developers. We shouldn't worry about it at all. Integration thing, same thing. Sanity testing and smoke testing, also interface testing and regression acceptance. Those 5 are performed by the manual QA engineers, and we will be talking about them shortly. Non-functional testing, because it basically requires a knowledge of some other tools, and usually so you would need like some specific person who knows how to measure performance, or you need a person who knows how to measure security, right? Manual QA engineers don't know how to measure security. We're not security engineers. Security engineers, they're absolutely different, type of an animal. It's a software engineers. They are trained to perform, implement protection for websites, protection for services. They know ridiculous amount of information. That's why they usually the ones who will perform security testing, because manual QA engineers or QA engineers in general know nothing about security, or know nothing about performance or load or anything like that, or stress or so on. That's why we really shouldn't worry about non-functional testing, because manual QA engineers don't really go there, except maybe few separate cases. For example, localization testing. So localization testing is when we test our software when it's translated to different languages, and we just making sure that everything looks fine. We don't have any weird layout issues. We don't have any weird translation issues. So manual QA engineers can absolutely test localization testing. Another thing, usability testing. Like usability basically means is how well users can operate the software, how well users can operate the interface. Also, you don't have to be a computer science degree major to test this particular thing. So that's why manual QA engineers also can test usability testing as well. But everything else, like load testing, performance testing, security testing, stress testing, nobody will ask manual QA engineer to touch these fields because they know nothing about it. Okay. Now, just because we don't do it, it doesn't mean we don't have to know what it is. We should be able to explain what this type of testing is and why it's implemented and what it does and so on, even though we're not even involved in it. Okay, because maybe they'll ask you during the interview. They'll ask you very common question is like, just list all the non-functional types of testing you know. That's it. If you name 6 of them, you're fine, even though you don't do it. You don't perform non-functional testing in your work. All right, guys, let's dive deeper into the definitions. So unit testing, it's a level of software testing where individual units, components of a software are tested. So when developers create their code, and they usually create, if you imagine, if you imagine a software, if you imagine a website, if you imagine a product, or the application, it consists of many different small things. So all the developers, you can have like 100 developers working on one application. They basically develop small little pieces. And according to their methodology, when you develop your code, when you basically write a new code, your functionality, you need to also write unit tests to test how your code works. So it's their job. We don't touch them. But technically, it's considered QA as well, because it is responsible for the quality of the product. So it falls under the QA textbook, but QA as a department, manual QA department, they have nothing to do with it. Now, integration testing is a level of software testing where individual units are combined and tested as a group. Again, usually made by developers, sometimes by QA engineers who specify in a certain technical area. Integration test, it's basically when all the components are being developed by developers, they are being integrated into each other through the code. And there are certain tests that, again, developers manage to test if everything, is glued together the way it's supposed to. If not, they have some errors and whatever. Again, QA engineers, manual QA engineers don't go there. But just by looking at the name, integration testing, we can already judge like what it does. It tests the integration of all little things, all little components, all little software, all little code and everything. System testing, it's pretty similar to integration, by the way. So it's the process that evaluates how the various components of an application interact together in full. System testing verifies that an application performs tasks as designed. So system testing, it's basically it's like an umbrella for different things, right? It's an umbrella for how well overall the whole system performs. And we know that the software has, like a client software, a client version, right? Like a mobile application. It has servers. Servers have their own code. There's hardware involved. So it's a complex. These days, systems are complex. We don't really care for a manual QA engineer. We don't really care. We only work with the final product. And most of the complexity is actually stays behind the behind the curtain, behind the screen. But for developers, for companies, things like it's important to check how your how many visitors your website can handle. What happens if, let's say, 100,000 people decide to like click on button on your website at the same time? What happens? Very simple basic websites, they'll break. They are not designed to handle 100,000 clicks on the same button within the same time, within the same second. But websites like Google, obviously, they are, that's their normal thing, that the users are clicking, button to search like 1 million times every second, maybe even faster. I have a question. The question goes like this. Can you provide an example of individual unit component, please? Well, it depends. Like if, let's say you have a pretty basic example, if you have a shopping website or Amazon, something like that, if you have a, your website, it's a e-commerce website, then you'll have a payment platform, which is going to be an individual unit, because payment platform is usually processed by, like a third-party payment systems like Visa, PayPal, whatever. So it's a component. Then you have your, shopping cart. Then you'll have your, I don't know, user management system, or billing system. So all those components, they eventually get integrated together and work together as a system. Hope that answers your question. Okay, so acceptance testing. So acceptance testing is a level of software testing where a system is tested for acceptability. The purpose of this test is to evaluate the system compliance with the business requirements and assess whether it's acceptable for delivery. So guys, I'll tell you right away, acceptance testing, or another name for it is release acceptance testing, is one of the most, how do you say, one of the largest, one of the biggest, one of the most important ones, one of the most common ones. So yes, so acceptance testing is the top priority for the company. And it's pretty much top priority for QA engineers as well. Because, as we will read again through the definition, it says, the purpose of this test is to evaluate the system's compliance with the business requirements and assess whether it is acceptable for delivery. So all the development companies, they don't create software because they like to, right? Because it's their dream. They were born to create software. No, they do it because they want to make profit. They do it because they have certain business expectations for their software to be released. In acceptance testing, basically, when engineers go through acceptance testing, we verify that the quality of this software, the quality of the product, satisfies our business needs. So from business perspective, everything that we wanted to accomplish, we think works okay, or we think works to a certain level, on a certain level. So we can then release it to our users and make more money. That's what acceptance testing is. Unlike other types of testing, acceptance testing just verifies that whatever the state, let's say our product or our software, our website, whatever is, satisfies our business criteria. Make sense? So the question is, okay, guys, about interview questions, don't worry about it now. We'll have many lessons going forward dedicated to your interview questions and answers. Now, another question is, acceptance testing, is that meaning the software meets expectations? Well, technically, yes, but what expectations? Each type of a testing is basically checks for certain type of criteria, certain expectations. So business expectations are different from technical expectations, and so on. Business expectations are probably the most important ones, although they correlate between each other. Customers' expectations, it's a third thing. It's a separate thing. A lot of things customers expect one thing and they get absolutely different thing, because that is what the business decides on doing. All right, guys, let's go forward. More types of testing. Yay. So guys, when I said about acceptance testing, let's talk about other things, other examples, other types of testing. Yeah. I'm sure that you somewhere at some point heard these terms somewhere. All right, so let's go over them. Alpha and beta testing. So alpha and beta testing, right? Type is it's a subtype of acceptance testing. Let's take a look at the difference. Alpha testing is performed to identify all possible issues, bugs before the product is released to the end user / public. It is usually done by designated testers, internal employees, and is done early on, near the end of the development phase and before the beta testing. So when let's say you work for the company and you have like 100 people there, right? 100 people. You have like 10 people for QA department and so on. So when developers create some software, right, they create whatever the new thing that it's not being exposed to the users, right? Maybe it's a new version of an application, maybe it's a new feature, you know, maybe new functionality, so something that users haven't seen yet. The first initial stage, when the software is somewhat ready to be tested, so at first initial stage, they will do a thing that is called the alpha testing. So alpha testing, it's a first initial look by anyone who's affiliated with the company. So if you're an internal employee, if you are, you know, whatever, the QA department, if you are product designer, if anyone who's internal user of this application within this company, and if they perform any types of check-in testing, you know, looking at the application before it goes to official like QA process, those are considered alpha testers. Some companies, they hire like a third party. For example, I was working for one of the development companies, and we would hire for our alpha testing phase, we would hire external company somewhere like in, you know, Eastern Europe to do like initial round of testing because it was cheap, right? Labor there is cheaper than here. So it would make sense to send them your version of a software first. They will find, you know, a lot of bugs or not find a lot of bugs, whatever. But you'll get that initial alpha testing phase covered. And then beta testing. So beta testing is a different thing. So beta testing is done by releasing a beta version of the software to a limited number of end users. So unlike alpha testing, beta testing is done by the actual users. So it's not done by the QA engineer, it's not done by the internal employees, and it's not done by anyone else. Beta version is released to the users, to the small amount of users usually, and they would be the ones who would check the quality first. For example, if you guys use mobile applications, sometimes maybe you see that when you go to the App Store or Play Store, there is a way on the page of an application to become a beta tester. They'll basically ask you if you want to become a beta tester or not. So beta testers are sort of like a volunteers. So they'll get this updated version of a software first before the rest of the users. And by looking at the performance, by looking at the data, by looking at the stats, developers basically will say if it's stable enough, if it works well, you know, they'll read through the user feedback, and they will then decide if it's okay to release it to the larger audience or not. Does it make sense, guys? Do I have any questions? Do QA, so the question goes like this: do QA testers needed for or even get access for alpha testing phase? In some cases, yes. Some cases, of course. I mean, QA engineers pretty much test all the time. That's their work, and they are required to, you know, they obviously do their testing all the time. But beta is a second step. It's a second phase, second stage. It's done when the when everyone during the alpha testing stage said that we think it's fine. So then they basically released the software to some number of actual users who are not affiliated with the company. Question is, are you going to show us? There's nothing to show. It's a concept. It's an approach. It's not a physical testing. That's just a concept. There's a lot of things here that are concepts that have nothing to do with the physical testing. We're not there yet. All right, guys, so let's move to the next type of testing. All right, so end-to-end testing. End-to-end testing. So end-to-end testing checks whether an application flow from start to finish is behaving as expected. Sometimes we call it a full user journey. So end-to-end testing is performed to identify system dependencies and to ensure that the data integrity is maintained between various system components and systems. All right, guys, so end-to-end testing, E2E, it's the, I don't know what do you call it, an acronym or something like that. You'll see it probably a lot when you apply for the jobs, or some people put it in a resume. It's a cool thing to use. E2E looks good. Anyway, why it's important. So E2E or end-to-end, it's an approach. It's an approach. It's a strategy of how do you decide to test the software. Example: let's say you work for the e-commerce website or the Amazon, maybe eBay, whatever. So when you work for this, so you work for the product like that, you know that the most important part of your software is basically for users to go in to search for the product, right? What is the full user journey? Full user journey for, let's say, Amazon. You go to the Amazon, you search for whatever, jacket, jeans, shoes, dress, doesn't matter. You go through the search, you find the dress you want to buy, you add it to the cart, you check out. That's the full user journey. And it's the most important user journey for this product, because that's how business makes money. Everything else, it's of course it's important. Yeah, it also needs to be tested, but it's not the full user journey that Amazon needs to, basically worry about. So in my company, in my product, we do have a list of user journeys, and usually if let's say you have total number of test cases, like in 1,000, around 1,000, then for user journeys you may have only like 20 user journeys, the main ones, maybe 30. You can expand it as well, but those user journeys, they'll cover flow from start to finish, and this flow basically will say if the product works well for the customer or not. Does it make sense? It's like all the features are working as expected. It's not all the features. It's the features that are super important for the main user flows. All the features may mean, like, is your FAQ section in some chat room works well? FAQ section is important, right? But it doesn't make you any money. It just helps users. It's not a main user journey. So even if it doesn't work, well, it's not a big deal. Question is, what is the difference between system and end-to-end testing? Well, system testing it's a very broad term that covers a lot of different things, and mostly I think it covers it can cover like non-functional requirements. It will cover like how well your system performs, how fast is your system, how fast is your server, how fast is your loading time, for different system components. And end-to-end is basically, it's more of a functional approach. It means like, can user go through the full journey without breaking it or not? So if user or QA engineer can go through the full user journey, everything works fine. We don't care how well it works at this point. All right, so let's move to the next. Let's move to the next important slide. This slide is very important. And I think we're a bit behind. So let's do the speed run. Testing types: regression, smoke, and sanity. Those you will do as a QA engineer a lot, because that's probably, that's one of the top, the most famous, important, popular types of testing that are done while testing certain product. So I'll tell you the difference, and hopefully you'll understand the difference. Let's start with the smoke testing. So smoke testing is performed after receiving the software build to make sure that the critical functionalities of the program are working fine. It is executed before any detailed functional or regression tests are executed on the software build. So let me read the sanity first, and then I'll explain the difference. Sanity testing is performed after receiving a software build with changes in code or functionality to ascertain that the bugs have been fixed and that no further issues have been introduced due to these changes. And I'm pretty sure that most of you look at these two descriptions or definitions and say, well, it's basically the same thing. No, it's not. Let's break it down. So the smoke testing basically means that you will, when you need to test an application, think about it as a pool, right? The pool, the swimming pool. Imagine a swimming pool, and the swimming pool is basically the software that you need to test while swimming. It's a weird analogy, but hey, just stay with me. And for smoke testing, your swimming pool is going to be really wide and not deep. So basically, during the smoke testing, you cover all the major functionalities or all the major features of your application, but you don't really go that deep. You don't really try and test every little detail. Your job, when someone says, can you just do like quick smoke test or smoke check for this software, it means that you only need to spend maybe an hour, maybe 2 hours to go over the basic main flows, like the basic main functionalities, and see if you don't experience anything weird. Again, it's a very short test, and it will cover all the application, but you don't really go deep. You basically just barely touch each of the component to make sure that nothing weird is going on. Why it's important? Because let's say there was a major code change. Developers did some, they did some changes with the code. And before you would go and dive deep into hours of testing, you need to do a basic test to make sure that the application starts. Let's say it's a mobile application. So you launch the application and it starts. It doesn't show you like empty screen, doesn't crash. It doesn't show you basic like errors or something. So the application starts, and then let's say you work for an Instagram, right? So for an Instagram, you only have maybe like 5-6 basic functionalities, like uploading an image, commenting on some other's image, liking an image, sharing an image, recording a story. So you only have like 5-10 major things that you need to check in order to understand if the smoke test, from smoke test perspective, the application works okay or not. Generally, smoke test is the first, it's the first round when you catch early bugs, because at the early stage of development by the developers, it is pretty common to make some very big and obvious mistakes, to the point of, let's say, when you start running your application, or if you open your website, it's going to be empty. It's going to be, there's nothing going to be there. Maybe your mobile application will crash. Maybe it doesn't load. So it's obvious things, and obvious things are easily uncovered by smoke testing. Of course, when you will be working for an actual company, you'll be working for the you'll be testing product. You will know what you have to test. They will give you a list of things that will be included in the smoke test, plan or something. It's not like you'll have to guess. But even if you have to guess and you have an application like Instagram, you pretty much know what to do, what to check. And they'll give you, okay, you have an hour. So make sure you test everything in Instagram, not everything. Make sure you test major flows in Instagram within an hour. It's easily done. It'll take you like 20 minutes. So that's what smoke testing is. So you cover, imagine the pool again. The pool analogy kind of got stuck with me. So now every time I teach, I usually give it to people. So it's a pretty wide coverage, but it's not too deep. So we don't really go deep into like real details of every element. Now, sanity testing. Now let's talk about the sanity testing. Sanity testing is performed after receiving a software build with changes in code or functionality to make sure that the bugs have been fixed. So for sanity testing, imagine, for example, if you work, where do you work? Let's make it Facebook. You work at Facebook. And there was a bug, there was an issue where users couldn't like other posts or couldn't comment on other posts. Happens, Facebook people, they they have their software is pretty buggy. I see a lot of bugs on Facebook, so it can happen. So the bug is getting reported, right? So someone says like, hey, we have this thing broken, it doesn't work. Users can't like, can't comment, whatever. So developers basically go in, they change the code and they change something, right? They fix it. And then they say like, you, John, you're a QA engineer, please do the sanity test or sanity check for this specific issue. So rather than, unlike smoke testing, when you go and cover all the functionality, but not too deep, for sanity test, you cover only that area that was affected and you go deep. So if the comment section was affected, then you check, comments, all the ways of commenting, attaching gifts, attaching videos, attaching likes, shares. So you basically spend pretty much the same amount of time that you do when you do smoke testing, but you don't test all the application. You dive deep into that specific area where there was a code change. Does it make sense? So both those types are initial checks. They don't really go as a standard practice, as a standard way of testing things. They don't really fall under the standard cycles, right? Those are performed during very short and occasional things, like if the bug was fixed, the bug is fixed, if they touched some functionality, then you need to do like sanity test. If it's a new development, if developers are just performing some initial things and they want to make sure that at least the software can be launched without an issue, then it's a smoke testing. They'll give it to you. They'll give you all the details. The order, we will not talk about an order yet because it's not important. For now, and during the interview, if you would be able to explain, first of all, I can guarantee that your manager probably wouldn't know the difference between smoke and sanity. Oh my God, I see people working in QA engineering for 10 years and they can't tell you the difference between smoke and sanity tests. They just don't know, and it's fine. If I wouldn't teach in this class, I would have a hard time as well. Those are close things. It's easy to confuse, even at my work. They're totally lost about smoke and sanity testing difference. But I'm a teacher and I have to know. That's why I should explain it to you. That's how I know. But people who don't touch, who just work there for years, they might not know a difference. So the fact that the person who will basically be interviewing you may not know the difference is also pretty common. If you would like Google difference between smoke and testing and sanity, and you would go to like other websites, you'll see so many mistakes, like people claiming one thing is correct while other people will be claiming the other thing is correct. It's a very common thing to not know to not know everything, right? But if you would be able to tell the difference during an interview, I'm sure you'll get at least few bonus points because others probably will not. All right. So regression testing. So regression testing, it's somewhat similar, and it's more of a concept than a physical thing. None of these types of testing have anything to do with the physical testing. It's an approach that is applicable during the certain situation or a certain point of development of a product. So regression testing is performed to confirm that a recent program or code change has not affected existing features. So basically, regression testing is when we know that developers did some code change, we need to make sure that it didn't break anything else. Because regression bugs, regression issues are probably the most common things that we experience. When developer changes the code in order to fix one issue, they may introduce two more issues. That's just how it works. That's totally normal. And regression testing is basically focused on making sure that after developers fixed one thing, they didn't break two other things. I hope that makes sense. We usually work with a thing that is called full regression. So full regression is done at the end of the cycle. So after the software is already developed, after the software is basically fully tested, like separately, all the different features and components are tested. So full regression is basically going through the full list of your test cases. So if you have, let's say, 1,000 test cases, so all the key engineers, they go through all those 1,000 test cases to make sure that we would check everything as much as we can. Usually takes time, obviously, and mostly it's done manually. So for full regression, depends how many people you have in a team. It may take like a couple days, it may take a day, depends. But usually companies say like, okay, we need it to be done in 3 days. So we have like 5 people, there's 1,000 test cases, there you go. They basically split the test cases between each other, and they go just by the list, making sure that the final version will not have anything weird. So the question is regression testing, how testers know where the code change is. Well, we have, when we use our task management systems or task management tools, we see that there was a bug, for example, like there was like Jira. I'll show you the Jira later, obviously not today, but we see the ticket, there was a bug, and we see that it was fixed. So when you know that the bug is fixed, you know that every time developer changes something in the code, there is always a risk for regression bugs. So he fixed one bug, introduced 2. So you already know that there's a possibility for a regression. Same thing goes for when they have planned changes to a software. So if they add like a new button, or if they will add a new field, you'll see the ticket. It's going to be like well, it's called a ticket. That's what we call it. You'll get familiar with that shortly. Yeah, so basically you'll see the ticket and you see the description. It's going to be the changes that were made are affecting, let's say, search. They're affecting, this button and that button. So in our mind, we already know that there may be some other bugs that possibly were introduced by that change. They're called regressions. All right, let's see if I have any questions. We can move on. So the question is, so after fixing bugs and getting new build, do we need to do all these tests? It depends. It depends. You definitely need to verify the bug, verify the fix. You need to verify that the issue was actually fixed. Because sometimes the developer will change like one line of code. They will try it one time on one computer or one browser, one mobile phone, and they say, oh, it's fixed, it's working for me. But when QA engineer starts to test, we try like on, say, a few different devices, or we try on a few different browsers, right? And maybe it's fixed in one thing, but we are still able to break it. So basically the job for QA engineer is to break stuff. The job for software developers is to fix stuff. And then this cycle goes continuously. It never stops. We are breaking stuff, developers are fixing stuff. We're breaking stuff, developers are fixing stuff. Somewhere along the way, we find the product with the quality that somewhat satisfies our users. All right, guys, let's see what other questions do I have. Is regression under functional testing? I mean, it depends. Regression, if let's say, the code change would address the performance of a website or the speed of how things load, then it's not going to be under functional requirements, because it would require us to measure, how fast the website loads. So I don't think these are actually, technically they don't really relate. They're basically, it's an approach that can be functional, can be non-functional. Although in the books, in the textbooks, in the QA methodology books, most likely you will find them under functional types, which I can argue with, but So another good question is, do the requirements tell you which test to use, or do we discern that based on what the stage the product it is? You basically decide. It's going to be obvious, guys. The concept itself right now, it's a bit complicated, but when you will work for as a QA engineer for, let's say, a couple of months, it will be crystal clear to you. It's actually not that complicated. So just judging by the fact or the instance of why do you need to test something, you'll be able to tell which approach you should take. Okay, it's not going to be complicated, I'll guarantee. In fact, again, these are more of a this is a theoretical part, right? Theoretical part is something that you need to know, you need to learn, like at school, right? But you may not need that, or you may not experience fully what we teach during the actual job. But it's not the point. The point is all that stuff can be asked during the interview, and I expect you to be able to at least give like 1 or 2 sentences about each and every type. If they ask you questions, what environment you're working on, we're not covering this yet. We'll cover that later. All right, guys. So performance, load, and stress testing. You know what? I don't really want to spend too much time on this. Those are the Those are the examples of a non-functional testing that are performed mostly by specific dedicated engineers. QA engineers, manual QA engineers don't do that stuff. But you'll get a presentation. Feel free to read about them. Now, something that is important, another set of concepts. Let's talk about positive, negative, and boundary testing. Now, this is important, and it's the concept that you need to understand, okay? So let's cover this slide, and I want you to try to focus and try to understand the idea behind this. So let's start with the positive and negative first. Positive and negative. So positive testing uses the valid data as input, checks whether an application behaves as expected with the positive inputs. Negative testing ensures that your application can gracefully handle invalid input or unexpected user behavior. All right, guys, I'll give you a very basic example, very basic example. So probably, when you go to some website, and this website is basically age restricted. Maybe you've been to those, and it can be like shopping for alcohol, whatever. There's some website that basically needs you to provide an input, and your input would be your age, let's say, yeah. And after that, let's say if you provide an age of 21 or 18 or older, you will be able to proceed and maybe shop for whatever, alcohol, beer. Yeah. So for this software, you have the first time you go there to the website, let's make it a website, you have basically one input field, one text field or text box, where you have to type your age, and the button that says verify or submit or okay, something like that. Yeah. We know, since we work for this company, we work for this website, we know that you can only be accepted or taken forward with the flow if your age is, let's say, 18 or older. Let's make it 18, although in some cases 21, whatever, it doesn't matter. We have a condition. Condition says that only if your age is 18 or above, we can let you use our website, right? So the positive test would be to check that the system will let us in if we enter 18 or up to 150. So if we have a limitation, let's say 18 to 150, if we enter 18 and above, system should work. So far, so good. Yeah, that's the positive scenario. Because why do we call it positive? Is because think about positive testing as a valid data. And what valid means is it means that what we accept, what our system is designed to accept in order to let user continue. Any questions about positive result, right? Well, you guys can ask any questions. I'll continue with the negative testing. So the negative testing basically says that what happens when user enters something outside of what we expect. Like the system expects to have, let's say, a number between 18 and 150. That's a positive scenario. But what if our user enters 17 or 16 or 0 or 265? Or maybe our user decides to enter, their name. What happens then? So all these cases are called negative scenarios. And by negative, we mean that the input the user will provide is going to be invalid. The input is going to be not the one we expect in order to let the user in. So the point of negative testing is to make sure that the system will behave as expected, the system will not break. If I go into this website and let's say I'm 15 years old or 16 years old, and I put my age, right, 16, and I click on the button, the system should say like, oh, I'm sorry, you can't come in, you're not old enough. Yeah. Now it's a gracefully, so that's what we call gracefully handle user input. What if I decide to put my name there? The system basically should say like, please enter age, like don't enter text, enter age, right? And not let us in. Again, another example of how gracefully system should handle invalid input. It's going to be more clear going forward. Right now, it's a bit confusing. I understand that. It's going to be more clear when we'll be writing test cases and test scenarios, because that's basically how it is. That's basically why it's important. It's important because when we'll be writing basic test cases or test scenarios, we will need to test the positive and we will need to test the negative. So, and I'll give you examples later. Now, another thing that I should cover, even though it's like sort of like an edge case. What time is it, guys? Whoops. All right, so we're really short on time. Oh, we're actually almost done. Cool. All right, so the boundary testing. What do we call it boundary testing? The boundary testing, it's a technique where test cases are designed to include values at the boundaries. So if the input data used is within the boundary value limits, then it is said to be positive testing. If the input data picked is outside the boundary value limits, then it is a negative testing. So guys, the boundary testing is where we have boundaries, we know our limitations, and we need to test a scenario to be as close to the boundaries as possible. So what are our boundaries in this case? Let's say 18 and 150. So the boundary testing would check 17, right? So 17, maybe 18, 19. For 150 would be to check 149, 150, 151. So we basically covered that, +1, -1 to our boundaries. Why? Because in software engineering, the most mistakes when it comes to calculations and computations would come with basically one-off digit. Like it's pretty common to make a mistake where, where you wanted to make a 20 a result, and because of the computer system, you'll make it 19. So that's why boundary is always checked. Does it make sense? Boundary testing is so boundary testing basically means that we need to check the boundary around what is expected. Let's say if like 45, if we test our system by entering the age of 45, is not the boundary testing. It's a positive test. We should be able to proceed with the age of 45, but it's not close to the boundaries. It's pretty far from the boundaries because the boundaries are 18 and 150. The 17, on other hand, would be an example of a boundary testing, but it also is a negative testing because it's outside of the range. Like age of 1 is, what is it, guys? What is the age of 1? Is it a negative or a positive testing? If we try to proceed with the website with the inputting, providing the age of 1. Negative. Awesome. Good job. What about 151? Is that a positive or a negative? Negative. Okay. Is 151 a boundary condition? It is boundary because it's right there. It's right there next to our boundaries, and our boundaries are 150. Why our final age where you can be accepted is, it says 150. So 151 would be totally boundary. 152 probably not. 149 and 150 also. I usually test such conditions. I also consider them boundaries or close to the boundaries. So 149, 150, 151. That's what I usually test. Same goes to if you have like you have to create a username or you have to create a password, and they say it should be like minimum of 8 symbols long, right? So your boundary testing will be to check 7 symbols, 8 symbols, and 9 symbols. Make sure that 7 symbols is too short, 8 symbols should work, and 9 symbols should also work, obviously. All right, guys, so I think it's pretty straightforward. I see that a lot of you got it, so my explanation wasn't that bad. Is boundary testing, it's a testing or it's a technique? It is a technique. Everything that we basically teach you during today's lessons are closer to techniques rather than the actual testing. But they may ask you this during the interview. Again, that's why it's important. And guys, you always have this presentation. It's going to be with you. You can always come back. You'll have this recording. You can also rewatch. So don't worry about it if you missed on something. Yeah. All right, guys, let's talk about the bugs. I think we're done with the testing types. Let's talk about the bugs. So when there's an issue, right? When there's an issue, something is not working the way it's supposed to be working. We as a QA engineers, besides the fact that we need to identify an issue and report it, we need to classify it, meaning that we need to provide an initial assessment of severity of an issue, like how bad this issue is. And this is totally subjective. There are no black and white criteria here. This is subjective, but it somewhat falls under the general understanding of QA, of software concepts. So bug classifications, canonically, there are 5 of them. There's sort of like a standard. Blocker, critical, major, trivial, minor. Sometimes by priority, you will see P0 would be the blocker. P0 would be the worst one. For example, you go to the website like Amazon, right? And it shows you 404 error. It's an absolutely worst case scenario that may happen. Another example of a blocker is, for example, let's make it an Amazon again. All the payment systems are down. So none of your users can, basically purchase items. It's another example of a P0, so horrible, very bad situation that really, really affects your business, and you lose like $100 million in second with this particular issue being, exposed to the public. So that's what we call a blocker. Critical, for example, is so what happens when an issue comes up? The ticket is created with classified as a blocker or P0. Basically, what it means is that whoever is involved in this area, right? They drop whatever they're doing at the moment. Nothing else is important, and they switch to, addressing this situation. They're switched to this, to fixing this bug, identifying the issues, trying to analyze it. They switch it right away. Okay, so their top priority is to fix that, that problem, that issue. So that we call P0, or priority zero. And by we, I mean in software development, in IT world. Critical, it's a second stage, right? We call it critical, or sometimes high, or sometimes P1. You can see different ways of, calling those things, but they mean the same thing. So critical means that it's a pretty bad bug, it's a pretty bad issue, and it definitely needs to be addressed as soon as possible. But it's not, it doesn't block anyone, meaning that we don't have to drop everything you're doing. You basically prioritize, you say, okay, yes, it's a pretty bad bug, we should probably fix it today, maybe tomorrow, right? We will identify the timeline, we will identify the ways to fix it, we'll say, yes, it's our top priority, but we're not going to drop everything just to fix it. So critical, that's what basically critical means. Major issue, or P2. So this one was P1, P2, P3, P4. P2 means that, it's a bad bug. We should probably fix it, this week or maybe next week. P3 or P4, in some companies, they are never getting fixed. So if you file a bug and you put it P3 or P4, they are never going to get fixed. Next year, unlikely. Likely that by the end of the year, they will just delete all the P3 and P4 issues, and they will never be fixed. Again, it's subjective. There isn't any like really objective criteria, and the more you work in the field, you will feel it basically. You'll get a hold of this faster. You'll be able to analyze and prioritize issues better. But if you, let's say you start working for the company, and instead of critical, you call it major, or instead of, trivial, you call it major, it's absolutely fine, because there's always a second pair of eyes, mostly project managers, or sometimes product managers, or maybe QA managers. There's always someone else who's going to check what you are doing. They'll look at the lines, the list of tickets. And if they see that, maybe it's not as important, they'll basically change the priority or classification. It's absolutely fine. So it's absolutely fine when, Q engineer files it as a critical, and it's definitely, or they file it as a blocker, and it's like major. They basically will deprioritize it, and it's not a big deal. So it's not a big deal if you make a mistake. It kind of makes a big deal when there's an absolutely huge blocker, and you for some reason file it as a trivial or as a P3. It means that it will go like, after all the most important tickets, and it's going to be lost somewhere. So that's kind of like a bad scenario. So if you just joined the company, if you're not sure, you can always ask your teammates, or ask your QA lead, or you ask your QA manager. They will be happy to help you. It's absolutely fine to ask, right? So the question is, what bug classification is error 404? Again, it depends. It depends. If it's an error 404 after you try to pay for your product, it's definitely a blocker, and it happens to everyone. But if it's error 404 when you try to get, when you try to read the FAQ section of how to deliver products from East Asia to Australia, and that specific page doesn't open, it's okay. Yeah, it's bad, but it's not the blocker. So another question is, so why should P3 and P4 be deleted? P3 and P4 be deleted because by the time developers will go through all the P1s and P0s and P2s, QA engineers will file another 300 of P0s, P1s, and P2s. And P means priority. So you always push something that is more important to the top. It means that everything that is created, as a trivial or minor P3 and P4, it's always going to be pushed down. And believe me, developers usually have a lot of work to. It's not like they fixed all the bugs and there are no more bugs. There's always going to be bugs. There's going to be hundreds of bugs. And the more code changes they make, the more features they add, there's going to be more bugs. So by the end of the year, you end up with way more bugs or way more bug tickets that you have in your system than from the last year. And that's why they even do what is called the bug ticket cleanup, when they basically say like, oh, okay, we have like 700 P3 and P4 bugs, and we know, judging on our schedule, that we're not going to fix it this year, so we will delete them. We don't really care about them. We know that we're not going to fix them. Okay, makes sense. So another question is, will they list requirements for each classification for blocker and critical? No, unlikely. No, you have to figure it out for yourself. At first, just think from business perspective. When you think from business perspective, it works. It's like, how bad is this issue affects your customers? Like, how much money does your company lose by having this bug? Because that's basically what this thing is all about. It's not about if we like this color or not. Maybe this color isn't green enough. We want this color to be more green, or maybe it's supposed to be blue and it's yellow, right? But realistically, it doesn't really affect your business model that much. Again, it's subjective. It's hard to say. You'll figure it out. Don't stress about it that much. Another question is, do testers also report P3 and P4? Of course. If you have let's say if you have if you think like there's a typo, there's or maybe localization bugs, when you feel like the word is all barely fits after the translation, the word barely fits on the button, you file it as trivial or minor. You don't really file it as a major. It's not a major problem. It's a minor issue. So you'd file it P3 or P4. Another question is, does not fixing P3 and P4 bring side effect to whole system? Well, usually when you have P3 and P4 bugs, they aren't, either they're not important functionally or they're not a functional issues. There's something that doesn't really affect the performance, that doesn't really affect the, doesn't really affect the business model or something. So there are still issues, but they're still not appear as expected, right? But they are not important enough for us to fix it because we have more important things to do. Another question is, so would most UI bugs be considered P3 and P4? Not necessarily. If you have an application and your main menu icon looks like twice the size of what it should be, right? It's definitely not a P3 or P4. That's your main menu, and it should look the way it's supposed to, right? Even though it's maybe just a cosmetic bug. It may not affect the functionality, but it can be just a cosmetic. But still, since it's a major element, it's a major UI element, it's a major icon on your device or on your website, you would definitely need to fix it. Yes, typos are usually, they're not going to be as important as other stuff. Formatting, like a text size, positioning, scaling, and so on. All right, guys. Another thing, so bugs priority, severity and priority. Severity defines the extent to which the defect can affect the software. In example, impact that a given defect has on the system. Priority defines the order in which we should resolve a defect. So in some systems, they have two things. They have two measurement systems. The severity is how bad is the bug technically, and priority is how fast do you think it should be fixed. In reality, they mean mostly the same thing. In most of the systems that I've seen recently, they only have like one field for this, just one priority or just one field severity, and you basically just find something in the middle and decide what it is. In fact, I should probably delete this slide. It's more confusing. Is bug and defect are the same? Yes, bug, it's a slang name for software error or software defect or software issue. So yeah. All right, I think we already covered bug reports during our first class, right? We're vaguely touched, but when we create an issue, when we create a bug, it should have some information. It should have some components. So the bug title is, let's imagine we have an issue where we go to the website and we see error 404. Very common. Bug title we write it down. We need to create a short, very simple explanation of what went wrong. So an attempt to access website results in 404 error. Bug ID is given by the system. We shouldn't worry about it. Severity, priority. Again, it's something that maybe we need to provide as an assumption. It's absolutely fine. In most cases, it's going to be just one. So priority or severity, and you just decide on what it is. It's like high or P0, P1, P2, whatever. Assignee is the person who's going to be later in the chain will be responsible to taking care of this ticket. You may be a project manager, you may be a developer. It will be basically explained to you during the class. I'm sorry, during your work. It's not a problem. Reporter is yourself, right? That's going to be your name. Status we will cover later. But status is when it's a new ticket, when it hasn't been looked at by anyone else, it has a status of new. Then what happens is, let's say developers look at this ticket and they say, okay, yeah, it's a real issue, we need to fix it. Then the status, they change the status to like accepted or in progress or something like that. And after they fix it, it will be changed to fixed, and then after QA engineers usually verify it, we mark it as verified, something like that. Again, something that you shouldn't worry right now. It's going to be a very simple process. I'll guarantee it. That's how it goes. So environment details, we need to specify which software and hardware did we use in order to see this issue. So if we used Windows, you put Windows. If we use Mac, you put Mac. If you're able to reproduce it on Chrome, put Chrome. If you're able to reproduce it on Internet Explorer, put Internet Explorer. In some cases, some bug is only, let's say, observed on, let's say, Internet Explorer, but doesn't happen on Chrome. That's why you always provide this information. You can put it here like able to reproduce on Internet Explorer, but works fine on Chrome, or whatever, on Chrome browser. Steps to reproduce is basically a short list of steps how to get to the issue, and then expected result and actual result. This is important. So out of all these, the important fields are the title which you create. Obviously, priority you have to analyze. Environmental details you have to provide. That is also important. Steps to reproduce Expected result is what we expect to see when the case works as expected. So when everything is fine, what do we expect to see? What do we expect for this to happen? An actual result is what went wrong. So what do we see and why do we report this bug? Okay. Okay, so let me go through the questions. The first question is, how you know it's high or low? How can you find out? Ask your coworker. So the second question is, so you should test all environments and report every environment you can reproduce it in. Well, it depends. If you have, it depends on the problem. Sometimes you don't have to test all of them. If let's say, the website has a 404 error, most likely it's something with the server. So for you, it's only important to test it, let's say, on maybe Chrome and maybe another browser, any other browser. If you see on both of them, it means most likely that all of them are broken. So you don't have to test like 6 browsers every time. In some cases, when you're only able to reproduce issue on one browser, but it doesn't, you're unable to reproduce it on another browser, you need to probably check some other browser and maybe another one. When its issue is like pretty kind of like we call it browser specific. Sometimes you only have one browser that you see this bug on. So then you say, okay, this is browser specific because I can only reproduce it on one browser. Another question is, if one bug is observed on multiple environments, do we create different tickets for all of them? No. If it's the same issue, you only create one ticket, but then in the environment details or in like a notes or in the comment section, you say that I've tried this browser, that browser, and this browser, and they all have this issue. Usually the cause would be the same. There's no point in creating different tickets because it's the same issue. And basically, this is how bug report looks like. Well, it's an old UI for Jira, but right now Jira looks a bit different because Jira is notorious for changing their interface every 2 months. So, but as you can see, it's a very basic page which has like all the things that we mentioned, we went through today. Description, priority, title, and so on. Right, this one we will not touch, it's not important yet. All right, guys, so I think we actually are done with our material. Do you have any questions? The questions that are related to today's class. Let's try to make it simple. Let's see. Let's see. The PowerPoints you will get after the class. Right. And along with the recording of a video. Another question is, do we have to memorize the definition of all testing types for the interview? For the interview, yes. So far, no, but you'll have time to prepare for the interview. And also, you don't have to memorize it. If you can explain it in your own words, that's absolutely fine. But if you can't, just memorize the definition. I would suggest you to just read about it to be able to understand it first, and then you can always, memorizing definition is not complicated. Another question is, which browser will you say you found the most issues occurring from? Definitely Internet Explorer, number one. When we will learn how to use Jira? Shortly, probably in a week or so, maybe longer. You don't need Jira now. Jira it's very basic thing, and we only use it to file bug reports. So there's no point in learning Jira now because you don't really know how to. There's nothing for you to test yet, or there's nothing for you to report. Another question is, are we going to get directions on how to download Jira? Jira, you don't have to download. Jira, it's a web service. It means that you will be able to access it with your browser. It's a website. And yes, you'll get all the instructions when the time comes. The question is, will the terminology be reinforced through future lessons? We definitely will prepare you with sharing our common things we talk, the common terminology we use, just because it's common. It may help you during the during your work or during your interview. Are there assignments, homework practices, etc. for each lecture? You will have later, you will have a homework. You will be practicing during the internship. All right, guys, so many questions that are unrelated to today's class. Please address all these to the support@jobeasy.co. All right, guys, so we covered today's material. Let me remind you one thing, that tomorrow's class, same time, same link, but in order to access, you will have to get a password. In order to get a password, you have to do two things. It's pay the registration fee and sign the contract. If you still haven't processed it, just finish this process, right? If you did, then you will receive the access and same link, same everything, but it will ask you for the password. So just enter the password tomorrow. Okay, so today's class was free. Thank you guys for being with us. I hope the lecture was useful and informative. And hopefully we will see you on our future lessons. All right. Okay, guys. Bye-bye.